Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. From today I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not check out my channel, please follow my channel. If you like my channel, then please do like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will discuss about the next important topic of energy bands and charge carrier in semiconductor device, that is the extrinsic Fermi level position. That means we know that is extrinsic semiconductor is two type, N-type semiconductor and P-type semiconductor. Then what is the value of extrinsic Fermi level for N-type semiconductor and for P-type semiconductor? What is its position? Okay. So, we know the concentration of electrons in the conduction band. We already talked about this topic. What is this value? This is the N0 equal to Nc exponential or e to the power minus Ec minus Ef divided by Kt. That is the equation 1. So, we know already this topic. We already know this value. That is Nc is the effective density of state function for electrons in the conduction band. Ec is the conduction band age. Ef is the Fermi level energy. K is the Boltzmann constant and T is absolute temperature. So, what is the concentration of electrons in the conduction band? That is N0 equal to Nc e to the power minus Ec minus Ef divided by Kt. So, from this equation we can write it also Ni equal to Nc e to the power minus Ec minus Ei divided by Kt. Why N0 is represented by Ni? Because this indicates directly electron concentration. Directly the electron concentration for intrinsic semiconductor. That is, we can write this equation 1 as equation 2. That is Ni equal to Nc e to the power minus Ec, and Fermi energy is represented here by intrinsic Fermi level, that is Ei divided by Kt. So, this is the equation 2. So, what is the next equation? That is the whole concentration in the valence band. Similarly, we can get that P0 equal to Nv e to the power minus Ef minus Ev divided by Kt, and this is the equation number 3. And this equation is also write it as Pi equal to Nv e to the power minus Ei minus Ef divided by Kt, and this is the equation number 4. So, first we talk about the electron concentration in the conduction band, then we talk about the whole concentration in the valence band and its intrinsic Fermi level position also. For intrinsic semiconductor, we know that we can consider the electron concentrations and the whole concentrations are equal, but for extrinsic semiconductor, we don't take this type of any consideration. So, separately we can consider this equation, this 4 equation. Okay. Therefore, From the equation 2 and from equation 4, we obtain what we obtain? Taking natural log both sides of this equation 2 and equation 4, what we get? We get EF equal to EI plus KT ln N divided by N0 divided by Ni. This is the first equation. That is, we get from equation 2, and from equation 4 we get EF equal to EI minus KT ln P0 by Pi. Ni is the electron concentration and Pi is the hole concentration. Okay. So, if we taking natural log both sides of equation 2 and equation 4, first equation we get, that is EF equal to EI plus KT ln N0 divided by Ni, and the second equation we get EF equal to EI minus KT ln P0 by Pi. So, this two equation is the extrinsic Fermi level position. This is for electron concentration or for n-type semiconductor, and this is for hole concentration, that means it is for p-type extrinsic semiconductor. This is the n-type extrinsic semiconductor Fermi level position, this equation, and this equation is the p-type Fermi level, p-type extrinsic semiconductor Fermi level position equation. Okay. So, here we can consider two consideration, that is EF greater than EI. That means when Fermi energy is greater than intrinsic energy. That means when this condition occur, that means EF is near to the conduction band. That means this position. This is conduction band, we know, and this is valence band, right? When EF greater than EI, this condition occur. That means EF is near to the conduction band edge. This is EF. Okay. That means EF is greater than intrinsic Fermi level energy. Okay. So, this is true for n-type semiconductor. For n-type semiconductor, we know that is the electron concentration is greater than the intrinsic electron concentration. So, Fermi level is near to the conduction band edge. This is for n-type semiconductor. And second consideration is when EF less than EI. That means when Fermi energy is less than the intrinsic energy, and this consideration is for p-type semiconductor, and for this we can say that the Fermi level is near to the valence band edge, and this is true for p-type semiconductor. For p-type semiconductor, we know that the hole concentration is less than the intrinsic electron concentration, right? So, this is the Fermi level which is lie near the valence band edge, and this is for p-type extrinsic semiconductor. So, this is the value, or this is the equation for position of extrinsic n-type semiconductor and p-type semiconductor, and this two condition is also occur from this two equation. First condition is for first equation, this first equation, and second condition is for true for this equation, right? I hope you understand. So, here we end today's topic. Thank you. I hope you love this informative session of NTA UGC NET or West Bengal set exam. If you like my video then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.